Okay, now that we looked at our first example, we started with the object way out here, okay? Now, I could bring it in a little bit closer to here and see what it does. But we're not going to do that. We'll go in even closer yet, okay? So again, first thing I'm going to do is mark the focus. So I go halfway closer to the mirror. There. I'm going to take a new object and I'm going to put it right on top of the center. Why would I do that when originally we were here? Now we've moved to here. What about the space in between? Turns out you're free to draw in this space in here, but you're going to find there's nothing different about it at all. You're just going to get more of the same. But something happens when we land right here on top of the center. So let's take a look at what our results would be. The first problem comes when you try to draw that ray that's the easiest one. A ray from here, from the tip, through the center, to the mirror. There is simply no way for a ray to do that. There is no straight line path from the tip to the tail, which is where the center is, onwards to the mirror. So it can't be done. Does that mean the image is dimmer? No. There's still an infinity of light coming off of this thing. If I put this arrow in the middle of a football stadium, all the hundreds of thousands of people could see it. It's got endless beams of light coming out of it. We could track any ray we so choose. It's just the easiest ray of all is not available to us. So we have to make do with the others we can get through. So we can still send the ray in parallel and still have it come out through the focus. That ray we still have access to. We can also do the ray that goes in through the focus and then it leaves parallel. And we have an image. Because all the light that originally left this arrowhead reassembled itself right down here. So we seem to have reassembled an upside down image almost right there. Now there is a third ray we could use if we want to. Any beam that goes into the vertex is going to ricochet off at the same angle. Now I want to match that same angle and I know it's going to go here. So I'm cheating on how I'm doing the exact replica angle. I've made the angle here the same as the angle there. And what should happen and what has not happened is it would have reassembled the arrow bang on this location. This one would have created an identical image in every way to the original. It's just upside down. Why did I miss? Why is the intersection here not directly under there? Literally making an error no thicker than the line width of a pencil is enough to throw this one off. This made a duplicate copy exactly the same size as the original. So you went, when you were way out here, you went from seeing a small little version upside down to now an equal sized one. And that's what's special about the center. It will make a replica image of the item. Now what does that look like as salt? Well, the size is now the same. The location is at C, or you can write it as, and it's still inverted and it is still real. When you use the small mirror in class, this is the impression you get when you try to touch your own fingerprint, touch your own reflection. It's a one-to-one. Another way of doing this is if you actually put a person here, just their upper torso, they would look like a king or queen on the deck of cards. It would be an exact mirror image of themselves. And we can demonstrate that in class. So this is what happens when the object is at C. Okay? You don't need to worry about the one ray. It's simply cut off, but again, there's an infinity of rays that you could trace, and the image occurs where these rays re-intersect. Tiny error either way, I don't really care about, but this one is very critical to get it nailed right, and it's very hard to do accurately every time.